Okay, so in these videos I am going to explain how you would do the homework problems. I'm not going to do your exact homework problems, but I'm going to tell you how you would do it by working a similar example. So here we have a copper sulfate solution was prepared, a copper 2 sulfate solution was prepared by dissolving 6.56 grams of copper sulfate in sufficient water to give 226 milliliters of solution. What is the concentration of the newly prepared copper sulfate solution? So all you need to know for this is that molarity equals moles of solute over liters of solution. And in this problem we are looking for concentration, so we're looking for molarity, so we already have this set up right. We're given mass, and so we need to be able to change mass to moles. So we need to know that moles equals mass divided by molecular weight. And we need liters of solution, and we are given milliliters, and so we need to know to go from milliliters to liters, you divide by 1,000. So let's say I had a similar problem where I had a silver nitrate solution was formed by dissolving 53.2 grams silver nitrate in enough water to make 632 milliliters of solution. So first I need to get the moles of silver nitrate. So I need to get the molecular weight of silver nitrate. And to do that, I will go to a periodic table. And not to PowerPoint. And silver is 107.87. And nitrogen is about 14.007. And oxygen is 15.999, and I have 3 of them, so I'm going to multiply that by 3. And by the way, the calculator that I'm using here, it says TI-30X Pro. In the United States, it'd be a TI-36X Pro, and I recommend it very strongly. It's a non-graphing calculator, so you can use it in a lot of classes, and it's just really, really a good calculator. It doesn't cost much, little, just over $20. Okay, so I need to add these together. 107.87 plus 14.007 plus 3 times 15.999, 169.874. And so my moles will equal the mass, which is 53.2 grams, divided by my molecular weight, 169.874 grams per mole. .313 moles. So my molarity is my moles of solute, 0.313 moles, over my liters of solution. It was given to me in milliliters. To turn milliliters to liters, I divide by 1,000, which is the same as moving the decimal 3 places to the left. 0.632 liters. And I get 0.496. Would be the molarity on that one. So that's how you do that one. Okay, this next one is just converting between Kelvin and Celsius. Now, I don't know if you're supposed to use 273 or 273.15, but to go from Kelvin to Celsius, subtract 273 from Celsius to Kelvin, add 273. So if I had what is 42 degrees Celsius in Kelvin, we just do 42 plus 273 equals 315 Kelvin. What is 320 Kelvin in degrees Celsius? Take 320 minus 273 and 47 degrees Celsius. This one is asking to write these elements in order of decreasing electronegativity, highest electronegativity first. So when we look at a periodic table, we know that our electronegativities follow the following trend. So the most electronegative is going to be fluorine. Fluorine is the most electronegative. And then the least electronegative, well, francium is radioactive, but it gets, so the trend is like this, with more electronegative right here. And less electronegative down here. So you get more electronegative going across and more electronegative going up. Sometimes it's hard to tell. Like, what if you were asked to compare between oxygen and chlorine, for instance? Well, in that case, sometimes you just have to look at a table of electronegativities. And so here, when we look at our table of electronegativities, we can see that fluorine is 4.0, oxygen is 3.5, and chlorine is 3.0. So we know that oxygen has a higher electronegativity than chlorine. So let's say that my problem, instead of the one that we had, was to list decreasing electronegativity, and let's say I had oxygen, chromium, barium, and sulfur. So highest electronegativity first. So I know the higher electronegativities are going to be oxygen and sulfur, and I know oxygen will be more electronegative than sulfur. And then the nonmetals are going to be more electronegative than the metals. And then I've got chromium and barium, and so chromium will be more electronegative than barium, so it would go in that order. So that would be the order of electronegativities. Okay, balance the following equations, use lowest possible coefficients. Alright, so the first one is a combustion, C10H4. Okay, that's not very many hydrogens. Okay, I use the following method for balancing combustion equations. So when I have a hydrocarbon and I'm adding oxygen and making carbon dioxide and water, this method is, because you can get some weird numbers, but this method will always get you the right answer in the fewest number of steps. So start with your carbons. I've got 12 carbons here, so I need 12 carbon dioxides. Save the oxygens for last. The reason you do that is because oxygen is in two different things over here. Now I need to balance my hydrogens. I've got 10 hydrogens, so I'll put 5 in front of the waters. Now I'm going to check my oxygens. I've got 24 from here and 5 from here, so that gets me 29. So I need to have 29 oxygens, but these are O2s. So to have 29 of them, I'll put a 29 halves there. You don't want to have a fraction in your balanced equation, so then you multiply everything by 2. And now if you look, everything will be balanced. I've got 24 carbons, 24 carbons, 20 hydrogens, 20 hydrogens, 48, 58 oxygens, and 58 oxygens. And those steps will work anytime you need to balance a combustion equation. Let's do another one. Let's say I had C6H14 plus O2 yields CO2 plus H2O. Balance the carbons, put a 6 here. Now balance the hydrogens, put a 7 there. Check our number of oxygens. That's 12 plus 7 is 19, so it'd be 19 halves. Multiply through by 2. 2C6H14 plus 19O2 yields 12CO2 plus 14 H2O. Check. 12, 12, 28, 28. Let's see, 24 plus 14 is 38, and 38. So if you didn't have a fraction here, you would not need to multiply by 2. So if I had C6H 12 plus O2 yields CO2 plus H2O. So balance the carbons, balance the hydrogens, And now I'll check my oxygens. I have 12 here, 6 here, that's 18. So put a 9 there, and there, that's balanced. So that's how you balance a combustion equation. Okay, now let's say you have an equation with some polyatomic ions. So let's say I had lithium acetate plus potassium sulfate yields potassium acetate plus lithium sulfate. When you have these polyatomic ions, if the polyatomic ions are not breaking apart, you can think of them as whole units when you're balancing. So you can think of it as, okay, I've got one SO4 here and one SO4 here, and keep those balanced. But let's look first at our metals. So I've got 2 lithiums here, so I need a 2 here. So now I've got 2 acetates here, so I'll need a 2 here. And now I'll check my potassiums. I've got 2 potassiums, that works. I've got 1 sulfate and 1 sulfate, so that works. Okay, now when I have subscripts, let's say I had magnesium nitrate plus potassium hydroxide yields magnesium hydroxide plus potassium nitrate. So I can see that I've got 2 nitrates on the magnesium nitrate, so I can put a 2 here. Now I've got 2 potassium, so I can put a 2 here. I've got 2 hydroxides, 2 hydroxides, 1 magnesium, everything balanced. Okay, now let's say I had barium nitride plus water, and I make barium hydroxide plus ammonia. Okay, so this one is a little trickier. One thing that you can do is you can always think of water as HOH. And so, had an OH2 there. So, I see that I've got 1 barium here. I usually start with the thing that is like the weirdest, and by the weirdest I mean not hydrogen or oxygen. So I'll put a 3 here. And nitrogen, I've got 2 of those, so I'll put a 2 here. So now I see I've got 6 OHs and 6 H's, so it looks like a 6 here will do it. So let's see. So this gets me 12 total hydrogens, and I have 6 hydrogens here, and you multiply here, so this is 2 times 3, I have 6 hydrogens here, so that's 12. I have 6 oxygens, and here I have 6 oxygens, so yes, that works. Now let's take a look at a combustion that's not a hydrocarbon. C6H12O6 plus O2 yields CO2 plus H2O. Still start with the carbons, so we've got 6 there. Then go to the hydrogens, and you've got 6 there. And then your last thing will be to do the oxygens. The only thing is the oxygens will be a little different this time, because you have to count the oxygens in both of these. That's 12 plus 6 is 18. And here, I already have 6 over here. I don't want to mess with those 6, so I need 12 more, so I'll put a 6 there, and that'll be balanced.